Hello everyone, in this video I'm going to do two examples that will convert the Newman projections to the bond line and eventually to the Fischer projections. So the Newman projections could be actually of two types. I could have the front carbon where it's going to be lined up, and then you're going to have the bottom ones to the left and right. So that's like an inverted Y. Or you could have the front carbon where it's pointed down, and on the top it's up, left and right. So it's like an actual Y form in that particular case. So this is the second form of it. So there are two different ways of drawing it depending on how your front carbon is looking in the Newman projection, and you want to follow those protocols. Suppose I'm looking this from the right side. So when I'm looking this from the right side, where I have my eyes right there, so then you can clearly see that this part of the molecule is going to be facing you, so that's going to be coming out of the page, and this part of the molecule is going to be going back in the page. So based on that, I can redraw this just to kind of assure that how it's going to be looked. So I would have this guy right here coming out of the page, and also this one coming out of the page. Since I'm looking at from the right side, and then as far as your inverted Y go, like in this one, your structure or your skeleton is gonna more or less look like this. I would have something like this. All right, so where this would be your front carbon and this would be your back carbon, and these side grips are going to be your other in and out other substituents there. But remember, your front and your back, when you're drawing this inverted Y form, needs to be slanted from the left to the right, going up, like in this particular case. So if I follow that particular scenario here, so maybe I can just focus on my front carbon first, and maybe I can just draw in a Sawhorse projection first. So that's your front carbon, so I can see what's really going on in my front carbon. So I have in the front carbon got this atoll that's pointed up, so that's how I exactly want to draw it. So remember, this is the front, and then your hydrogen is onto the right side here, and that's coming out of the page. So I'm going to go ahead and draw that exactly how it looks like. And then you're going to have, let me change this. I'm going to have chlorine that's going to be going back in the page. So these guys are going to be going back in the page. And I'll draw that as it is. And now when I'm drawing the back carbon, so for right now, what I'm going to do is just draw that straight up here. And then I'll worry about drawing it in a more presentable way in a minute. So this is going to be your back carbon here. So that's the back carbon, and that's the back carbon here. So on the back carbon, you can clearly see how this OH is literally opposite to the atoll of the front carbon. So this OH needs to be pointed exactly down opposite to the atoll group. And then the other thing I got here, obviously, is this methyl group that's going to be pointed to the right side, and it's also coming out of the page. So I want to make sure I draw that exactly how it looks like, pointing to the right side, coming out of the page. And I have this hydrogen that's actually going to the left side, and that would be going back in the page. So this should be going back in the page like this. Okay, so now if I want to go ahead and draw that in a more presentable way, I would use this skeleton that I actually have drawn earlier. Okay, so on this skeleton, remember, this was right there is the connection between the front and back. Okay, and then on the front carbon, I have this atoll group that's going to be pointed up. So I'm going to go ahead and draw another one right there. So that's your this atoll group right there, and that's that atoll group that's pointed up. And then I also have the hydrogen that's going to be coming out of the page. So I'll have it something like this, and then I would have the chlorine going back in the page. And on the back carbon, I can clearly see that we have this OH that's literally opposite to the atoll group and needs to be pointed down. So that would be right here. So that OH is right there. And then you also have this methyl group that's to the right side. I want to just draw that exactly how it looks. And then this hydrogen is going back in the page here. So that's how you're going to be converting this Newman projection to the skeletal form. And I can worry about what the chiralities are. And in terms of the chiralities, I would say this is going to be 1, that is going to be your 2, that's going to be 3. So that's going counterclockwise, but then your hydrogen is actually coming out of the page. So I would have to flip what I originally see. So it's actually, reality is going to be clockwise. So that is going to be an R. And when I'm looking at the second one, this would be 1, that would be 2, and that would be 3. Your hydrogen is going to be 4. It's already back in the page. I don't need to flip it. That is also going to be an R form. Now, if I want to go ahead and convert it to the Fischer projection, I can take the left side to be the top on the Fischer projection. So let's say this is the left side of the molecule, and that's the right side of the molecule. So the left side of the molecule is going to be the top portion, and the right side is going to be the bottom of the Fischer projection. Typically, the one that's most oxidized is on the top, but it doesn't really matter as long as you get the structure really right. And if I want to just kind of stick with the left being the top, that's fine as well. So I have 2 chiral centers here. So let me just go ahead and draw the line right here first. And then on the top, since I have this ethyl group, I want to go ahead and draw that right here. So that's your ethyl group on the top. That would be your ethyl group on the top here. And then you have a chiral center obviously here, so it's going to be one of them. And your second chiral center is right there. And then on the bottom, I'm going to have the OH. So I just want to make sure I draw the OH as it appears for right now. Now, how exactly it's really going to be, we can test that in a little bit. But for right now, I'm just going to go ahead and randomly put on the first chiral center. I can put chlorine here, I suppose. I can put chlorine here, and I can put hydrogen here. And for the second one, I'll just go ahead and randomly put, again, the hydrogen on the left side and the methyl on the right side, so I don't really have to put anything. Now, I don't know exactly if this is the right Fischer projection, and you can actually check that by looking at their chiralities. So if I look at the top one, suppose, so on the top one, I want to make sure it's actually an R because that's what it really is supposed to be. So this is going to be 1, that's going to be 2, and that's going to be 3. Your hydrogen is going to be 4. So for right now, it seems like it's going clockwise, all right? 1, 2, 3. It's going clockwise, but then your hydrogen is on the horizontal, which means that's coming out of the page. So I have to flip what I see here. So in reality, it's actually going to be in a counterclockwise, and that's going to be an S form. And we need that to be an R form. So to make this an R form, I can easily switch the positions of hydrogen and your chlorine. So I can put the hydrogen on the right side and I can put the chlorine on the left side. So now how does it look? I would have 1 here. So now when I'm following 1, 2, 3, it's going counterclockwise, but then when I flip it, because the hydrogen is still on the horizontal coming out of the page, it's actually going to be an R. So going from the skeleton to the Fischer, it's actually relatively easier because all you really got to make sure you have the correct chiralities or the stereocenters from the skeleton to the Fischer projection. Now I can do the same thing and double check the second one here. So when I'm double checking the second one, this would be 1, that's 2, that's 3, and your hydrogen is obviously going to be 4. So when I'm following the structure here, or the numbers here, that's a 1, 2, 3, that's going clockwise, all right? But remember, your hydrogen is coming out of the page, so you would have to flip what you see. So in reality, it's going to be counterclockwise, and it's going to be an S form. But what we really need is actually the R form, and to make this as an R form, what do we have to do? I can easily swap the positions of these guys. I can make the methyl on the left side and hydrogen on the right side. So then how does it look now? So we're going to have 1, 2, 3 here, and hydrogen is going to be 4. Now it's going to be 1, 2, 2, 3 is going counterclockwise, and when you flip it, it's going to be clockwise because your hydrogen is still on the horizontal. So that's going to give you your R form. So this is how you're really going to be converting, and there are other ways of converting the skeletons to Fisher, but I feel like this is probably going to be the easiest way because you can easily compare your RNSs in that particular case. And let's look at this next structure where I have the actual Y form, and we're still going to be looking from the right side. So I'm just going to go ahead and get my eyes down here just so that you're looking from the right side. And when we're looking at it from the right side, we still gonna have this um, right side coming out of the page, and maybe I can just go ahead and draw that so that it's easier for us to kind of look at it. So this is going to be coming out of the page, and then this is also going to be coming out of the page, and that also tells you that these guys will be going back in the page along with this is going to be going back in the page. So maybe I can go ahead and draw that in that particular form. So when you're going from, when you have the actual Y form, the skeleton that you want to focus on would look something like this. So this would be your front carbon and that would be your back carbon. So if you see the differences between those two, um, in the previous case, the skeleton was actually, I'll just draw that again, was something like this. That was your front and that was your back. And you can kind of see the differences now because it's an actual Y. The previous one was an inverted Y. So this is how you really want to kind of look at it. So when I draw this out in the Sawhorse projection, I can say this is my front. So on the front, what I got the OH literally pointed down, so maybe just draw that as it is. And then I got the hydrogen pointed to the right side, that's also coming out of the page. And then your methyl group to the left side going back in the page. So that was your hydrogen here. Oops. And that was your methyl group right there. And the OH is right there. So that's your front. And then your back carbon, and I'm going to go ahead and draw that pointed straight down for right now, and then I'll worry about drawing in a more presentable way in a minute. When I'm looking at the back one, I can see this hydrogen is pointed up opposite to the OH, and that's how I exactly want to have. This is going to be pointed up, and then I got this ethyl group right there is going to be to the right side coming out of the page, so I actually want to have that pointed like this way. And then your bromine is going to be going back in the page onto the left side. And I want to draw that as it looks. Okay, so that was your Sawhorse projection. It's usually easier to kind of draw it that way and then eventually draw it in a more presentable way. So obviously we're still going to be using this as our skeleton form. So maybe I can just go and copy that down here. So on your front carbon, the OH is going to be right here. And then you can see your hydrogen is going to be onto this side and your methyl group is going to be onto that side. When I'm looking at my back carbon, so on the back carbon, we're going to have your hydrogen right here. This is a hydrogen and the OH are opposite to one another, and that's how exactly you want to have in there as well. And then you're going to have this right here. This is an ethyl group coming out of the page, and then your bromine is going to be going back in the page. So this is how it's going to look like in the skeleton form. And I can certainly figure out its RNS. I'm just going to take out the front and back here. So when I'm trying to figure out the RNS on those guys, this would be 1, that's 2, that's 3, and your hydrogen is 4. It seems like we're going counterclockwise, but then your hydrogen is coming out of the page, so I'll have to flip it. So it's actually going to be clockwise, so that's going to be R. And when I'm looking at my next one, the bromine would get 1, this should get 2, this should get 3, and your hydrogen is on the plane, that's going to get 4. So this is going clockwise, but then we would have to flip it because your hydrogen is going on the plane. So when we flip it, it's going to be counterclockwise. So that's actually going to be an S as well. So you really have an R and S in this particular case. And when we're looking at converting that into a Fisher projection, let's try that now. Let me just go ahead and start that, saying that, okay, I'm gonna, whatever I have on the left side, I'm gonna make that as top, and the right side, I'm gonna make that as bottom on the Fisher projection. So that, okay, I have two chiral centers, obviously, so I'm gonna start with that bond first. And on the top, I'm gonna have the OH here. And obviously there's a chiral center. I'll worry about that, filling it in a minute. And there's another chiral center on the bottom here. And then on the bottom, opposite to OH, I really have the hydrogen here. So maybe I can just leave that as it is for right now. So that's going to be the hydrogen there. Now let's worry about filling the other guys. So we'll worry about the green chiral center first. So I have the methyl and hydrogen. Maybe momentarily I put the hydrogen here and methyl on the left side. And for the bottom one, let's suppose I put the bromine onto the right side and put the ethyl group on the left side here. All right. And now I can go back and double check if I got these chiralities to be right. So when I'm looking at the top one here, supposed to be R. Let's see what we got on here. This is going to be 1, that's going to be 2, and this is going to be 3. Your hydrogen is going to be 4. And when I'm following 1, 2, 3, it's going clockwise. But remember, in the Fischer projection, your horizontal lines are coming out of the page. So your hydrogen is actually coming out of the page. And now it seems like it's going clockwise, but in reality it's going counterclockwise. So what I have to make this go clockwise, in reality, I would have to swap the positions of methyl and hydrogen there. So maybe I put hydrogen here and methyl on the right side. So what would this look like now? Your hydrogen gets 4 and your methyl on the right side would get 3 now. So when I'm following this, it's going 1, 2, 3. That's going counterclockwise. And when I flip it, it would been clockwise. So it's actually going to be R. And that's what we're really looking for. We need to have an R there. And then on the bottom one, let's see what's going on. Bromine would get 1, this would get 2, this would get 3 here, and this is going to be 4. Now your hydrogen is already on the vertical, so it's already going back in the page, so I don't have to really flip what I actually see in terms of the rotation. So we already got 1 to 2 to 3 that's going counterclockwise, and I don't really need to flip it, so it's actually already going to be an S, and that's what we're really looking for. We need to have an S form in this particular case.